So this week in pre-calculus, we're going to learn about 8 important functions, and we're going to learn how to transform them. For example, we're going to learn about the function x squared, which is pictured here in the graph. It looks something like this. And what we're going to do is we're going to shift the graph. We might move it to the right 3 units. Or we might flip it upside down. We might stretch it. So we might do something like this. Or we pull this graph upward. And so we get a new function that looks sort of like this. And there's lots of things we're going to do. So to prepare us for this, I want to make sure that we can evaluate functions. We can plug things into our function because you're going to see a lot of it this week in pre-calculus. So let's see. Suppose that we have this function x squared. I want to find several things. I'm going to scroll down and show you everything that I want to find. So maybe you can copy all the problems down, and maybe you can watch me do one and you can do the other ones. But for this particular function, what I want to find is f of x plus 3, f of x plus 3. Notice the difference between these two. This plus 3 is on the outside of the function. I want to find f of negative x. Also negative of f of x. Again, notice the negative here. The negative's on the inside, and here the negative's on the outside. F of 2x. And then I want to take the 2 on the outside. And I think that's all for this problem. Yeah. So make sure you write all of those down, and I'm going to go through them one by one. And of course, you can always speed up the video if I'm going too slow or you just want to see the answers. So let's start with this one, f of x plus 3. This is saying, in my original function, wherever I see an x, I replace it with x plus 3. So this is going to be x plus 3 squared. Now we can FOIL this and simplify it, but what I want to do, and it's going to be very helpful for pre-calculus, is we're going to leave it just like that, okay? Now remember that the original function is x squared, okay? So I'm going to write this here. That's the original function. The next thing I want to find is the function plus 3. So that's taking our function and adding 3 on the outside. Do you see the difference here? The plus 3, this is on the inside of the squared, and this is on the outside. Again, our function is x squared. Now I want to find f of negative x. So we plug in negative x wherever we see an x. So this is the new function f of negative x. So f of x is x squared. What is negative f of x? So where does that negative go? Well, that says take the negative of the whole function. So this is negative x squared. Okay, and the last problem, I put the negative on the inside. Now we could simplify this. If you want to simplify it, this will just turn out to be x squared, because negative x times negative x is x squared. So I'm going to leave it like this though. And here this negative is on the outside. Okay, the other two, again, our original function is x squared. Here we're going to plug in 2x wherever we see an x. And this one says multiply our original function by 2. So the 2 comes on the outside of this function. If I squared this one, I would get 4x squared. So this, when I plug the 2 inside here, is not the same as putting the 2 on the outside, because on the other one I would get, if I wanted to take it out, I would get 4x squared. Let's try another problem. This time I'm going with x cubed. Let me show you all of the problems I want you to do. And again, you can pause the video, write them down, even try to figure out the solutions. So f of x minus 2, f of x minus 2, f of 7x, 7f of x, negative f of x, f of negative x. Is that all of them? Yep, that's all. Let's start with this first one. This one says plug in x minus 2 wherever I see an x. So this is going to be x minus 2 cubed. Okay, our function is x cubed. Now I want to take the function and subtract 2. So because I'm taking f of x and I'm putting this negative 2 on the outside, what I'm going to get is x cubed minus 2. Again, I want you to notice the difference. The negative 2 is in the inside of these parentheses. It's being cubed as well. Here the negative 2 is on the outside, so it's not inside this cubed part. Our function is f of x is equal to x cubed. Let's plug in 7x, so we get 7x cubed. The 7 is being cubed as well as the x. Here I want to put the 7 on the outside. Two more. This is our function, x cubed. Multiply it by a negative, we'll get negative x cubed. And this one says plug in that negative on the inside of this cubed. So we'll get negative x cubed. Okay, now I'm going to do something similar, but it's a little different. This time I'm going to give you a function, the absolute value of x, and I want you to write a new function which looks kind of similar to the function f of x, right? Here I have absolute value of x, here I have absolute value of x minus 10, and what I want to do is I want to write this function g of x in terms of f of x. Watch me do the first one, and then you should see what I mean by writing g of x in terms of f of x. So what's the difference between this function and g? Well, g of x is the original function with x minus 10 plugged in instead of x, right? So if I take my function f, which is right here, if I plug in x minus 10, what I'm going to get is the absolute value of x minus 10, which is exactly g. So this is how I want you to write it. Say g of x is equal to the function f with x minus 10 plugged in instead of x. Let me show you the other ones I want to do involving this function. So I want to write g of x is equal to 3 absolute value of x in terms of f of x. This one I want to write in terms of f of x. This one too. And this one. Don't think, is there any more? Oh, there's another one. So 7, and that's it. Okay, so let's see what we can do. So we did the first one already. Now let's go with this 3 times the absolute value of x. How does this look compared to this one? So what's similar here? This piece, without the 3, is f of x, right? So g of x is 3 times f of x. So we wrote it in terms of this function. How about this one? This new function g is our original function with negative x plugged in. If I plug in negative x, I get the absolute value of negative x. What about this one? This function g is the original function, and we subtract 8 from it. This function g is negative f of x. Now compare this to the other one where I had the absolute value of negative x. We plugged negative x on the inside. Here we're putting the negative on the outside. I think we had this one already. What I'm going to do is I'm going to change it just a little bit, and I'm going to make it 3 times x on the inside of absolute value signs. So g of x is going to be f of 3 times x. We're putting 3 times x inside this absolute value sign. And this one, this is f of 1/2 x. Okay, I think we're ready to move on to something that's a little bit more challenging. Here I'm going to give you a series of transformations. So we're going to start with a parent function. That's what you're going to hear me call these in my videos for pre-calculus. This is a parent function, and what I want to do is this is very similar to what we did in the very beginning. I want to take this function, so this function is called f, and I'm going to define a new function. I could call it g, and I could call this one h, but then especially if I have several things I want to do, I'm going to have a lot of functions with lots of different letters, and there's only 26 letters in the alphabet, right? So what I'm going to do is I'm going to call this new function, instead of calling it g, I'm going to call it f sub 1, or just f1. And then this function, which I'm going to manipulate this one, I'm going to call it f2. But like I said, you can call it this one g, you can call this one h, you can call it k of x, l of x. I'm just going to number them like this. And you're going to see me do that in my other videos. So what I want to do, first I want to find this. Okay, so f sub 1 of x, I want you to take the original function f and plug in x plus 2. So in other words, this is going to be equal to, plug in x plus 2, it's going to be x plus 2 cubed. Okay, now let's take care of this one. Here, this new function that I'm calling f2 of x is f1 of x, which we have written here, with a 1 on the outside. So I'm taking this function, x plus 2 cubed, and then I'm adding 1 to it. Okay, this is f1 of x, and then add 1. Let's try some more. Again, my original function, we're going to let it be x cubed. So let me write that here. I want to find these two functions. I'm going to put this one in blue. First, I want to find f, where we plug in x minus 1. So that's just x minus 1 cubed, plugging that into here. Now in green, I want to find this function. F sub 2 of x is where I take f1 and multiply it by a negative. So I take this whole function and multiply it by a negative. So the function is this piece, which is x minus 1 cubed, and I multiply it by a negative. So that's this new function f2. Let me show you, let's see how many more I have of these, and maybe you can pause the video and try them yourself. So let me put what the original function was right here. So we're going to find these two. See if there's some more. Oh, this is the last one for this particular section. So pause the video and see if you can find f1 of x and f2 of x. Okay, so f1 of x is 2 times this function, so it's 2x cubed. f2 of x is taking f1, which is right here, and plugging in wherever we see an x, x plus 3. So f2 of x is taking this function, and wherever I see an x, I plug in x plus 3. Easy, right? All right, let's switch to a different function. This is called the reciprocal function. It's 1 over x. Now do the same thing, the same idea here. I'm using a different function. So let's see if we can find f1 of x and f2. Let me show you all of them this time. So write them down, and maybe you can try a few of them. Pause the video. So f of x is 1 over x. I want to find these two functions. And then I've made it a little more complicated for this last piece. I want to find 3 functions. So f1, f2, and f3. And I think that's all for this problem. Let me just scroll down and make sure. It is. So let's start with this first one. Again, I'm going to do this one in blue. f1 of x says take f of x, which is 1 over x, and subtract 7. Easy enough. And then f2 of x says take f1, and wherever I see an x, plug in negative x. So this is 1 over negative x minus 7. And you can pull this negative in the front. Usually we take negatives out of the denominator and move it to the front. Okay? Let's try these. f1, wherever I see an x, plug in x plus 3 in the original function. So this is going to be 1 over x plus 3. For f2, this says take this new function. Sorry, this should be an f1 here. Just make sure I put that in the last problem too. I did. For some reason I forgot to put it here. I want to take f1 and I want to multiply it by a negative. Okay, so then just put a negative on the outside of f1. All right, now I have 3. Put a little bit of space here. So for the first one, plug in negative x. So f1 of x is equal to 1 over negative x. f2 says take f1 and plug in x minus 1 wherever I see an x. So f2, be careful here. This is 1 over negative, well here's an x, so I'm going to plug in x minus 1. So this is equal to 1 over negative x plus 1 because I'm going to distribute that negative. And then for the last piece, f3, this says take f2, which is right here, and add 9 to it. So f3 of x is 1 over negative x plus 1 plus 9 on the outside because that's the function here, and then I just add 9 to it. Let's move on. Okay, so now I'm going to give you more than one step to switch g of x to f of x. I'll go from f of x to g of x. So here we're going to give you the function f of x is the square root of x, and I want to convert f of x to g of x by using a series of transformations. I want to use a new function for each step. Watch me do a couple so you can understand what I mean, and then you can do some by yourself, like pause the video and then just check to see if your work is correct. Okay, so here's my function. This is my parent function, the square root of x. And I want to manipulate this one to look like g. Okay, so I'm going to start with f1. So what can I do to this function to make it look like g? Well, my first step is I can take f of x and I can plug in x plus 1. You see how I have x plus 1 under here? So we can let f1 be f of x plus 1, which is equal to the square root of x plus 1. You see how I've taken care of this plus 1 first? I'm not worried about this negative 4 yet, but I'm trying to make this look like this. I have 2 steps to take. I have to get a +1 and a -4 here. My first step is to do the +1. Now you can do the -4 if you want to do that first, but I'm doing +1 first. I'll show you the other way in just a second. So f(1) of x is going to be my original function with x + 1 inside. Now to make f(1) look like g, I'm going to define a new function, f(2). And what I'm going to do is I'm going to take this function, f(1) of x, which is the square root, and I'm just going to subtract 4 from it. If I do that, I'll get the square root of x + 1 minus 4, and so now my function f(2) that I defined, this is equal to g. Okay, so what I've done is I've made functions that eventually lead me to g. So I started with my function f, made a new function f(1), and that took care of the +1, and then I made a new function f(2), which took care of the -4. A second way to do this is you could define the first function, f(1) of x, as f of x minus 4. Okay, so here is f of x. So f(1) of x would be the square root of x minus 4, which takes care of the -4 first. And then you could define f(2) of x to be f(1) of x plus 1. So that's saying in my function f(1), wherever I see an x, I plug in x plus 1. So then f(2) of x is going to be the square root of x plus 1 minus 4, and f(2) of x is going to be g. It doesn't matter the order that you do this. The reason we're doing this is because what's going to happen, and you're going to see in the pre-calculus class, in the videos, that when you add 1 inside this function, that's going to move this square root function. So what's going to happen is the square root function looks like this. And by adding 1, that moves this graph over 1. And then you're going to erase this. And then by subtracting 4, that takes this graph, so this is the graph of f(1), and it's going to move your graph down 4 units. So this would be your new graph. And this is your graph f(2) of x. And when you're done with that, you see that that actually is equal to this function g. So the idea is you're going to try to graph this function g, and by doing these steps, doing each step at a time, you're going to be able to graph this function g. So instead of calling this f(2), you'll say, oh, this is actually g of x. Now, by doing it this other way is going to give you the same answer. So this, on the blue side over here, what you're doing is you're taking the square root of x, this is f of x, then you move it down 4, 1, 2, 3, 4, and you get this function here. And then this plus 1 means move it to the left 1. So you're going to end up with the same function by doing all of those steps. So what I'm trying to say is it doesn't matter, at least when it comes to putting stuff on the inside of the function and putting it on the outside, which order you take it. I just want you to get some practice with this because you're going to see it in those videos. Let's try another problem. So our original function, f of x, is equal to the square root of x. And what I want to do is I want to do the same thing. I want to take g of x, and I want to see how I can make f of x look like g of x. So I'm going to start by defining a new function. So let's go with f(1)x. What's something I can do to this function, f of x, my first step, to make it look like g of x? Well, there's 3 things you can do. First thing you can do, it does matter what order you do them, but you have to be careful, and I'll show you why. But you can multiply on the outside by a 4. That's something we can do. Or we could maybe, instead of putting this x here, we could put -x. That's a possibility as your first step. Or you could put x plus 1 and then worry about the negative x later. So there's 3 steps here. What I'm going to do, I'm going to take my original function and multiply it by 4. If I do that, I'll get 4 square root x. And I don't have exactly what I want, but I'm getting close. Now I'm going to define a new function, f2 of x. And what I'm going to do is I'm going to add 1 inside. So I'm going to take this original function, f1, and I'm going to put x plus 1 inside. And when I do that, I'll get 4 square root x plus 1. So I'm almost there. I just needed a negative, because this is the same thing as negative x plus 1, so I need to make this a negative. So my next step would be to take f2 and plug in a negative x wherever I see x. And that will give me this function g. Okay? And again, this will correspond to how you're going to graph this function. What you're going to do is you're going to take the square root of x. This corresponds to a stretch. This corresponds to moving the graph left or right. And this corresponds to reflecting it. So you'll see all of that. I just want to make sure you can get all of these pieces. Okay. Now, of course, I said there were other ways you could do this. Let's try a second way. You could define your first function. So ignore this. Let's say this is what we have right here, and I want to rework this one without putting the 4 in the front first. Well, you could say, oh, well, let's start by taking f of x and plug in x plus 1. If I do that, I'll get that this is equal to square root x plus 1. Then I could say, let's let f of 2x equal f1 with a negative x plugged in. That will give me the square root of negative x plus 1, which is almost what I want. I just need a third function, f3, where I take 4 and multiply it with f2, and that will give me what I want. Now you do have to be careful if you start with negative x first. So I'm going to show you one more way to do this, but you have to be really careful with negatives. So let's say what you wanted to do was define f1 as taking f and putting a negative in. So that would give you the square root of negative x. Then let's say you want to put inside here, you want to make it negative x plus 1. So you got to ask yourself, what do I plug in? And this is where you have to be careful. You would have to plug in x minus 1. And the reason for that is, when you take the square root, this is negative x minus 1, because you're taking the negative of x. So whatever you're plugging in for x. So it's kind of like you have to think ahead. If you distribute this, then you're going to get what you want, negative x plus 1. If you put plus 1 here, that would make this a negative 1, which is not what you want. And then your last function can be what you think it is, which is 4 times f2 of x, which is going to be 4 square root negative x plus 1. Okay, let's move on. Let's try this one. Now remember, our original function is the square root of x. So let's take the square root of x and make it look like g of x. The first thing I'm going to do, let's take care of what's inside. So I'm going to take f and I'm going to plug in x plus 2. So that will give me the square root of x plus 2. My next step, I'm going to take care of this negative. So I'm going to say f2 of x is negative f1x. And that will be negative square root x plus 2. Now I've taken care of this piece and I've taken care of this piece. Now I need to get this plus 4. So f3 of x is going to be 2 of x plus 4 on the outside, and I get what I want. So this is equal to g of x. Let's use a different function. Suppose we have that f of x is equal to x squared. Let's convert this function to g by using a series of transformations, and I want to use a new function for each step. So I want to make this function look like g. Okay, so we're going to define our first function, f1 of x. What can I do to this? Well, maybe I can put the 3 on the outside first. So let's take 3 times f of x, and that will give me 3x squared. Then I need a second function. Well, I'm going to take this function, f1 of x. The only difference is I need a negative 8. And so I'll get 3x squared minus 8, which is what I want. So I needed only 2 steps to get to g. So our original function is x squared. Okay, I have a lot of things going on here. Notice that I have a negative 4. I have a plus 2. And I have a negative x. That tells me I'm going to need 3 functions. Okay, I'm going to, now remember, you just have to be careful with the negative, but you can kind of do them however you want. Just with reflections, be very careful. Here I have negative 4 on the outside, so I'm going to do that one first. I'm going to take f of x, and I'm going to subtract 4. That will give me x squared minus 4. So I'm part of the way there. f2, I'm going to plug in x plus 2 into this function. Well, here is the function, and if I plug in x plus 2, I'll get x plus 2 squared minus 4, because I'm plugging it in right here. And then my last function is going to be f2 with negative x plugged in. So that will be, wherever I see an x, I'm putting in negative x. And that is equal to g. And I'm done. Let's see, I think this is the last problem. Let me just double check. Looks like I might have, nope, this is the last problem. Okay. All right, how many things do we have going on here? We have this 3. We have this 1/2 and this 2. My original function is f of x is equal to x squared. Okay, so I say we're going to have 3 functions, f1, f2, and f3. What is the first thing you want to do? You can do whatever you want. What I'm going to do, I'm going to go ahead and take care of this 3. So I'm going to take 3 and multiply it with my function f of x. And I always write out what I get, which is 3x squared, because that's the original function. The next step I'm going to do is I'm going to take care of this plus 2. You can do the 1/2, but you're going to have to be very careful. I'll do the 1/2 as my second step just to show you in a minute, but I'm going to take care of this plus 2 first. So I'm going to take f1, and what I'm going to put instead of x is I'm going to put x plus 2. So then I'll get 3x plus 2 squared. And then the last step would be to take f2 and plug in 1/2 x. And I'll get 3, here's the x, 1/2 x plus 2 squared, and that is my g of x. So write that down. I am going to switch these steps, and I'm going to show you what happens when I switch them. Okay, so let's say I kept this 3 on the outside, and then I said, well, I see a 1/2. That's what I want to do first. So I'm going to take f1, and I'm going to plug instead of x, I'm going to put in 1/2. And what I would get, since I have 3x squared, I would get 3 1/2 x squared. And then I say, oh, I see this 2. That's my next step. And this is where you would make a mistake. F2, you say, I'm going to plug in x plus 2. If you don't check yourself, 1/2, where I see an x, I'm plugging in x plus 2, look what happens. If you distribute this, you'll get 3, 1/2 x, and 1/2 of 2 is 1. And this is not the function, right? You have a plus 2 here, not a plus 1. And that's because you're distributing this 1/2. If you want to do it correct, you're going to have to make this a 4. So if you make this a 4, and then you make this a 4, this will become a 2, sorry, because 1/2 and 4 make 2. And then you'll get what you want. So my suggestion for you is to do things that are on the outside of the function first, like this number here, take care of that first. And then if you have like a plus on the outside, take care of that. Afterwards, what's on the inside here, if it's a plus or a minus here, you take care of that and then worry about whatever's with this x. So my steps would be take care of, so this is the first thing, take care of a number. So let me say, put it this way, of c times f of x or negative f of x first. So like here I had this 3 on the outside of my function, I would take care of that first. Then the second thing I would take care of is to take care of f of x plus some number b. So if I had a plus here and then some number, that's the second thing I would take care of. Then the third thing I would take care of f of x plus a number on the inside. So if there's, like here we had this 2, I would take care of that. And then the last thing I would take care of would be f of negative x on the inside or f of some number times x. Like here we had this number 1/2, I would take care of that. That would be the last thing if I have a negative x or a number, because remember what happened, we had something with a negative in here as well. We had the square root, I think it was of 1 minus x, and that would be the last thing I take care of. So numbers on the outside first, then addition on the outside, addition or subtraction on the inside, and it also, this is a subtraction sign as well. So, and then the very last thing is multiplying by a negative or a number here.